All right, boys and girls, for example 2, they basically want you to graph the arc sine function. So a couple things you should know. We've already graphed the parent function y equals sine of x. And remember right now for inverse, we're only looking at the domain from negative pi over 2 to pi over 2, okay? And remember the range goes from negative 1 to 1. So this is what the table would look like, and these are the values of all your x's and y's, okay? If I had to graph, I'd probably only use these points because these are easily, you're easily able to graph those, okay? But again, we've practiced graphing so many times, it should be fairly easy, okay? So these are all the values for sine of x. Now, if I want to graph f inverse of sine of x or arc sine of x, basically what you've learned in the past is whenever you do the inverse, your x and y switch. So now your x value should be -1, negative radical 2 over 2, negative 1/2, 0, 1/2, square root of 2 over 2, and 1. Okay, so what used to be your y is now your x. And now as far as your y's, what used to be your x is now going to be your y value. So this would be negative pi over 2, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, and pi over 2. Okay? So again, these values will never change, okay? Because that's basically the interval that you're looking at, okay? These values will never change. Now, if you are doing shifts or so any type of transformation or amplitude, of course, you're either going to multiply or add, and we've practiced doing that enough, okay? So in example 2, they actually want you to graph one of these, so, and they want you to do it by hand. So let me show you which one they want you to graph. Okay, so for example 2, they're going to ask you to graph y equals arc sine of 2x. So obviously this is the inverse. So I already gave you the values. So basically you're going to keep the same x's, but now notice we're going to multiply by 2. So your y values will change, okay? But you're basically going to have all the y values. So what I would do is just come up with your y values and check on decimals and just make sure you're accurate, okay? And I would just graph this on decimals and just check to see what it looks like, but then move on, okay? We're not going to worry too much about the graphs on here, okay? I just wanted to quickly show you this one. But that's it pretty much for this, just so you know your values, okay? All right, now we're going to be moving on. Okay, so now we're going to talk about other trig functions, and you can actually find this in your textbook as well on page 317. So I had already described arc sine of x. So now we're going to talk about these two inverses, okay? Arc cosine of x and arc tangent of x. So here we go. For arc cosine of x, our domain is going to go from -1 to 1. Our range will go from 0 to pi. So we're basically going to be looking at quadrant 1 and quadrant 2, okay? And for arctangent, our domain is basically all real numbers. And then our range will be pretty much between negative pi over 2 and pi over 2, okay? So similar to the sine. All right, awesome. Well, let's get started right away. Okay, so for example 3, we're going to find the exact value, and the first example that we're going to do is cosine inverse of negative square root of 2 over 2. Okay, so once again, I'm going to show you how to use the unit circle. So remember, okay, so here's kind of a hint, okay? For cosine, cosine refers to your x value. So, okay, so this is going to be a little bit different. So we're looking at what cosine, and I'm actually just going to use theta, okay? Theta is going to refer to our radian. What cosine of whatever radian value will give me our x. And then this case, our x will be radical 2 over 2, or the negative radical 2 over 2. So we're basically looking for cosine of theta is negative square root of 2 over 2. So what radian will produce negative radical 2 over 2, okay? And that's a way of thinking about it. So let's look. Now, don't forget that your range here for the inverse is from 0 to pi. So that means for the cosine is also from 0 to pi. So we're looking at basically half the unit circle, okay? So negative square root of 2 over 2. And again, it refers to your x value. So you should be looking at your x value, and that'll fall here, okay? Your x value at 3 pi over 4 is negative radical 2 over 2. So basically, cosine of 3 pi over 4 will produce negative radical 2 over 2. So the inverse should be, and let me write it in a different color so it'll stand out. It'll be 3 pi over 4. Because remember, we were looking for the, for the radian that will produce that, okay? So that's that. Okay, so now moving on to the next one. Arc tangent of radical 3. Remember, tangent basically goes from negative pi over 2 to pi over 2. So you pretty much want to concentrate on the first quadrant, okay? So, so just a reminder, okay? This is from your trig functions. Tangent is basically y over x, okay? So we're looking what will give you square root of 3. So this is where you have a little bit of thinking. So you have to actually look at your y and your x value, okay? So here we go. Obviously, when I think of radical 3, I should only be looking at pi over 3 and pi over 6 because those are the only ones with radical 3, okay? Now think, if you put y over x, will it give you radical 3? So 1/2 divided by square root of 3 over 2, will that give you radical 3? Or will square root of 3 over 2 divided by 1/2 give you square root of 3? Okay. And you should have guessed pi over 3. Okay. And let me show you why. Okay. Our y value here is radical 3 over 2. Okay. And if we divide that by 1/2, and I've showed you guys many times. Oops, sorry. It's the same as saying square root of 3 over 2 times the reciprocal, 2 over 1. And then what would basically happen is our 2's cancel, and then we're left with square root of 3 over 1, or just square root of 3. Okay? So tangent of pi over 3 will give me square root of 3. So if I do the arc tangent of square root of 3, that should be pi over 3. So that's my solution there. And this is my solution here. Okay? All right, let's do a couple more. And again, I kind of showed you the work. To be honest, I normally don't really need work. Okay, so again, try to practice using your unit circle so you can go a little bit faster. Okay, so you can understand your unit circle. Okay, let's do a couple more. All right, I gave you a couple more examples, so let's try these together. Again, you can always pause it and try these on your own, and then just hop back in the video and try these, okay? So for part A, I'm giving you arc cosine of negative radical 3 over 2. So remember, for cosine, you're pretty much sticking to the entire top half of the unit circle, okay? So cosine of negative radical 3 over 2. So again, remember, cosine refers to the x value. So you're looking for the x value that will give you negative radical 3 over 2. And so if you look at your x values, that falls at 5 pi over 6. Okay, so the radian 5 pi over 6 will give you negative radical 3 over 2. So that should just be 5 pi over 6. Okay. Cosine inverse of 0.5. Remember, if you're not going to see any decimals on your unit circle, but it's the same as 1/2. Okay, so cosine inverse of 1/2. Let's look for the radian that gives us 1/2. So look at your x values. Okay, And then again, look, we found it right away, pi over 3. So cosine of pi over 3 gives me 1/2. So this should be 1/2. Okay. Again, I really like using the unit circle because after a while, you get in the habit of basically understanding your unit circle a little bit better. Okay. So now we're looking for arc tangent of negative radical 3 over 3. Okay, just remember for arctangent, it could be a little bit tricky because it's basically y over x, okay? So you have to look at your y value and your x value. Okay, so remember for tangent, you're pretty much sticking to these, okay? None of these are negative, so none of these will produce a negative. It'll be its negative version, okay? So think about which one will give you negative square root of 3 over 3, okay? So once again, I will stick to either pi over 3 or pi over 6 simply because those are the only ones that contain radical 3 and radical 3, okay? So now if you're wondering, well, which one gives me 1/2 over radical 3 over 2 or square root of 3 over 2 over 1/2? Well, if you guys recall, we used this one earlier and that gave us square root of 3. So most likely it'll be this one. And if you're not sure, you just kind of do the work for it, okay? Just to show you. So our y is 1/2 and our x is square root of 3 over 2. So it's the same as doing this. 1/2 divided by square root of 3 over 2. Okay, remember right now it's not negative. Ignore the negative, okay? So it is the same as saying 1/2 times the reciprocal, which is 2 over radical 3. Now, what's going to happen is your 2's will basically reduce to 1, right? Remember, everybody likes to say they cancel, but they don't disappear. It doesn't become 0. So now it's the same as saying 1 over radical 3. But this is not the same, right? But if you recall, you're not allowed to have radicals in the denominator. So it's the same as multiplying by radical 3 and radical 3. And then 1 times radical 3 will just be radical 3. Radical 3 times radical 3 will give me 3. So now they're the same, but they're not identical. So we know that pi over 6 produces the positive version. So to get the negative version, we want negative pi over 6. Okay, so our solution here should be negative pi over 6. Okay, and that'll give us the negative version of that. Okay. All right, last one, guys. Tangent inverse of 1. Okay, tangent inverse of 1. Okay, so remember, again, that's your y over your x. Okay, so when will your y over your x give you 1? When they're exactly the same. See, y over x, if they're exactly the same, they're going to reduce to 1. So tangent inverse of 1 should be pi over 4. Okay. All right, awesome. Hopefully you were able to follow along and I was able to explain it. If you're still having trouble, well, I'll show you in the next example kind of a trick to double check yourself, okay? But honestly, it just takes practice. So the one that I want you guys to do now is the checkpoint on example 3.